A compound pendulum is defined as any rigid body of whatever shape which can rotate about a horizontal axis, passing through it, about the horizontal axis, passing through it, and capable to oscillate in vertical plane about a mean position is called compound pendulum. No ideal consumption are considered in this pendulum, so it is physically possible pendulum, also known as physical pendulum. Derivation of compound pendulum. For that, there is a figure. Consider a rigid body of mass m and center of gravity g. Center of gravity g Consider a rigid body of mass m and center of gravity suspended at s in vertical plane. Distance between point of suspension and center of gravity is L. When a body rotated in small angle theta, g shift to g dash. At g dash components at g dash, components of mg are mg sin theta and mg cos theta. Mg sin theta and mg cos theta. Only mg sin theta acts towards the mean position, which gives restoring torque. Now, from figure, restoring torque tau res is equal to minus mgl sin theta for small angle theta, sin theta nearly equal to theta. Therefore, restoring torque is equal to minus mgl theta. Also, applied torque tau a pp is equal to I alpha. I means moment of inertia and alpha means angular acceleration. I into d square by d theta. Since If we not consider any external agent, then applied torque tau FPP is equal to restoring torque tau RS. That is tau AP is equal to tau RES, or tau AP I d square theta by dt square theta is equal to minus mgl theta, or d square theta by dt square is equal to minus mgl by I theta, or d square theta plus mgl by I theta is equal to 0. Equation I. This is differential equation of motion of compound pendulum, which is similar to equation of simple harmonic motion, that is d square theta by dt square plus omega square theta is equal to 0. By comparing is equal to mgl by I, or omega is equal to root under mgl by I, or 2 pi f is equal to root under mgl by I. Therefore, frequency becomes 1 by 2 pi under mgl by I. Now, time period t is equal to 1 by f is equal to 2 pi root under I by mgl. Now, if an axis passes through its center of gravity parallel to axis of rotation, then from parallel axis theorem, if an axis passes through its center of gravity parallel to axis of rotation, then from parallel axis theorem, momentum is equal to ml square plus mk square. K is the radius of gyration. Now, equation 2. Now, equation 2 becomes t is equal to 2 pi root under ml square plus mk square upon mgl. 2 pi root under m common, l square plus k square upon mgl. Therefore, t is equal to 2 pi root under l square plus k square by gl is equal to 2 pi root under l plus k square by l upon g. Hence t is equal to 2 pi root under k square L plus L upon G is equal to 2y upon under L by G, where L is equal to k square L plus L. This shows point of oscillation lies below center of gravity at a distance k square by L. Here L is equal to k square L plus L is called equivalent length. Length of simple pendulum. Thus, length of compound pendulum is always less than equivalent length of simple pendulum. That is, L is less than capital L. Now, maximum and minimum time period. Maximum and minimum time period. We have time period t is equal to 2 pi roundel k square L plus L by G. Maximum time period may be infinite. That is, t is equal to infinite. For that, L should be infinite, which is practically impossible. L infinity is practically impossible. For that is, T max implies L is equal to infinity, which is impossible. When L is equal to 0, T tends to infinity, which is possible. Since L to infinity is practically impossible, so for L is equal to 0, pendulum should be suspended at center of gravity T. So T is maximum. Since L is equal to infinity is practically impossible, so for L is equal to 0, pendulum should be suspended at center of gravity. So time period is maximum. Now minimum time period we have t is equal to 2 pi under k square plus l square by gl, or t is equal to 2 pi under k minus l whole square plus 2gl upon 2kl upon kl, because a square plus b square is equal to a minus b whole square plus 2ab, or t is equal to 2 pi root under k minus l whole square plus kl 2kl upon gl. Time period is minimum when k minus l is equal to 0 or k is equal to l plus minus l. Therefore t minimum is equal to 2 pi root under k square plus k square by gl is equal to 2 pi, that's 2 square upon g. K. Therefore t minimum is equal to 2 pi 2k upon g. This is the required expression for minimum time period. So compound pendulum, any rigid body of whatever shape which can rotate about a horizontal axis passing through it and capable to oscillate in vertical plane about a mean position is called compound pendulum. No ideal consumption are considered in this pendulum, so it is physically possible pendulum, also known as physical pendulum. Consider a rigid body of mass m and center of gravity g suspended at s in vertical plane. Distance between point of suspension and center of gravity is L. When a body is rotated in small angle theta, g shifts to g dash. At g dash, component of mg sin theta and mg cos theta. Only mg sin theta acts towards the main position, which gives restoring torque. From figure, restoring torque is equal to minus mg L sin theta. For small angle theta, sin theta nearly equal to theta. Tau raise is equal to tau restoring is equal to minus mg L theta. Also applied torque is equal to I alpha. I is moment of inertia and alpha is angular acceleration. I into d square theta by dt square. Since when external agency are not considered, then applied torque is equal to restoring torque. Then we get the equation which is differential equation of motion of compound pendulum, which is similar to equation of simple harmonic motion. And by comparing, omega is equal to root under mg L by I, frequency is equal to 1 by 2 pi root under mg L by I, time period is equal to 1 by f is equal to 2 pi root under I by mg L. If an axis passes through its center of gravity parallel to axis of rotation, then from parallel axis theorem, I is equal to ml square plus mk square. So temperature becomes 2 pi root under k square by L plus L upon g. Hence t is equal to 2 pi root under L by g, L is equal to k square L plus L, which shows point of oscillation lies below center of gravity at a distance k square by L here. L is equal to k square by L plus L is called equivalent length of simple pendulum. Thus, length of compound pendulum is always less than equivalent length of simple pendulum. Maximum and minimum time period, we have time period t is equal to 2 pi root under k square L plus k square by L plus L upon g. Maximum time period may be infinite, that is t is equal to infinity. For that, L should be infinite, which is practically impossible. Since L is equal to infinity is practically impossible,